Welcome to Algebra 2, Unit 6, Section 4, Solving Polynomials, Factoring by Grouping. I can find the zeros of a polynomial by factoring, and I can apply zeros of a polynomial to a graph. So first what we're doing is we're going to review here factoring this quadratic function. So if you remember, when we factor by grouping, we have to multiply A and C together, right? So A is 2 in this situation, and C is 3. So A times C in this situation is equal to 6. So the factors of 6 that add up to 7. So those factors would be 6 and 1. So we're going to rewrite this by splitting this into 2x squared plus 1x plus 6x plus 3. I want to group these according to some characteristics. Okay? So 6 and 3 have the same characteristics. So now what we're going to do is we're going to group these with parentheses, and we're going to find the greatest common factor within each grouping. So in the first one, x is the greatest common factor, so we end up with x times 2x plus 1. 3 is the greatest common factor here, so this would be plus 3 times 2x plus 1. And we finish up with x plus 3 and 2x plus 1. It's really important that we end up with these two have to be identical. Otherwise, we're made a mistake. So in this case, our factors here are x plus 3 and 2x plus 1. Now, x-intercepts, we have to set each of these equal to 0. So we would say x plus 3 equals 0, and we come over here and we would write 2x plus 1 equals 0. So I'm going to subtract 3 from each side, and I've got x is equal to negative 3 for one factor, or one x-intercept. And 2x plus 1, I would subtract 1 from each side, so I get 2x equals negative 1, divide each side by 2, and x is equal to negative 1/2. So our x-intercepts are negative 3 and negative 1/2. So the solutions to this are the x-intercepts. So we would say x equals negative 3, negative 1/2. So another word we can add is the word zeros, right? The number that makes our polynomial equal to 0, that's what's called a zero. So that is that p of x would equal to 0. The x values where our graph touches the x-axis. Okay, a distinct zero is when the graph, right, crosses the x-axis at distinct points, not the same point. Okay? So if you have a quadratic, right? So if you had a quadratic function, right, it's going to have 2 distinct zeros. A cubic function would have 3, and so on. Okay? So let's talk now about these examples here. So this quadratic has x squared minus 4x plus 4. Once it's factored, it would be x minus 2, x minus 2. So the zeros in this case, well, you set that x minus 2 is equal to 0, and that would mean that x is equal to 2. And since they're both identical, there's only one 0. Okay, so the zeros are 2. The distinct zeros are the number of zeros, which is 1. In this second format, right, you'd say x plus 3 equals 0 and x minus 3 equals 0. So in this one, we subtract 3 from each side. We get x equals negative 3. Add 3 to each side here. We get x equals 3. So my zeros are negative 3 and 3. Now, how many distinct zeros do we have? We have 2. Okay. All right. So let's look at some more examples. X squared minus 6x plus 5. Okay. So if you remember, when we go to factor this, I'm going to end up with, right, we have clues here. So x goes in the front on both. It's the factors of 5, but they're both minus. So minus and minus. The factors of 5 that add up to 6 are 5 and 1. So I set each equal to 0. X minus 5 equals 0. X minus 1 equals 0. Add 5 to each side here. I've got x is equal to 5. On the right here, I have x is equal to 1. So the factors, okay, we would just write x minus 5, x minus 1. X-intercepts are 5 and 1, or 1 and 5. The zeros are 5 and 1. And if we wanted to be a little more, we could say the distinct zeros, there's 2 of them, right? All right. All right, so let's do this one again. We have to find AC. We can't factor 3 out of all 3 of these. If we could, we would. But since we can't do that, AC is equal to negative 36. Since this is minus, now we look for the difference, right? So the factors of 36 that are 16 apart, right? So in this case, we're going to go, those would be negative 18, or positive 18, negative 2. So I'm going to say here f of x is equal to, we'll say 3x squared, and we'll say plus 18 minus 2x minus 12. And so we're going to group this now, like here, and we include this sign here when it's minus. Okay? So f of x would be equal to, oops, we got an x right there, we lost it. There, I put it in late. 3 goes into both 18 and 3x squared. So 3, and there's an x in both. We forgot it for this 18, but I fixed that. So 3x squared divided by 3x gives me x. 18x divided by 3x is plus 6. Okay, negative 2 goes into both of these. And there's no variable in both, so we just stop there. And negative 2 goes into negative 2x, x times. Negative 2 goes into negative 12, 6 times. Again, we want to pay attention that these are identical. So my factors now are 3x minus 2 and x plus 6. So we're going to put that down here. 3x minus 2 and x plus 6. To find our x-intercepts, we set each of these equal to 0. So 3x equals 2. And we divide each side by 3, and I get x is equal to 2/3. So there's one of them. Over here we subtract 6 from each side, and x equals -6. So 2/3 and -6, right? And our zeros, we have 2 zeros, and they are, right? We have 2 zeros, and those are x equal to -6 and 2/3. Now, we get a little bit more difficult to work with. Okay. Now, we're going to use the same process. It's a little bit extra work, but we're going to just group these like this. And we can still factor these the same way we just did. So what's our greatest common factor here? And that's x squared. Right? So we'd have x squared. Divide that out and I get x plus 3. Our greatest common factor here is -4. So we factor that out and we get x plus 3. So we know we did it right because we have these identical. So now what we're going to do is rewrite this as f of x is equal to x squared minus 4 times x plus 3. And look at what we have here. We have a difference of 2 squares. And those are easy to factor, all right, because those are both perfect squares. So this is going to be x plus 2, x minus 2, x plus 3. So now we're going to take this and we're going to set each factor equal to 0. Okay? So now we end up with x equals -2 here, right? I subtracted 2 from each side, add 2 to each side here, I got x is equal to 2, and I subtract 3 from each side here, and I get x equals -3. So my factors are x plus 2, x minus 2, x plus 3. Our x-intercepts are -2, 2, -3. And the zeros are, there's 3 zeros, right, of x equal to 2, x equal to -2, 2, and -3. Okay, now let's do another one here. Now, let's talk about this. How do we know? All right. Well, one of the things you want to do, you look at this here, and you can see both of those have a common factor of -9. Right? We could take -9 out of that. So those have a common factor of x squared. Right? So we would be able to do this by grouping. So let's go ahead and do this by grouping again. Okay, so f of x equals, the greatest common factor between those two is x squared. So I divide that out, I get x minus 2. Greatest common factor here is -9, so -9. And this is a hint, too, that they're going to see the same thing here, x minus 2, right? -9, x divided by -9 is x. -9 goes into 18 minus 2 times. So our next hint that we're on the same path here is we have x squared minus 9, x minus 2. We have a difference of two squares. X squared is a perfect square. 9 is a perfect square. So we can easily factor that out. X plus 3, x minus 3, x minus 2. Set all our factors equal to 0. X plus 3 equals 0. X minus 3 equals 0. X minus 2 equals 0. Okay. So now we'll go and say, okay, set each one, right? X plus 3 equals 0. Subtract 3 from each side. X equals negative 3. Add 3 to each side. X equals positive 3. Add 2 to each side. X equals 2. So we're going to set our factors in here. And then we're going to list our x-intercepts, and that's going to be negative 3, 3, and 2, right? And our zeros will be, there's 3 of them, right? X equals negative 3, 3, and 2, right? We have 3 distinct zeros. Okay. So let's talk about graphing. How do we go about doing that? Okay. So if you remember our factors here, right? So we can take that directly from this problem right up here, right? X minus 5, x minus 1, right? So we did this problem earlier, so go ahead and write them in. X minus 5, x minus 1. And our zeros were 1 and 5. So what can we do with this? All right. Well, we can go to 1 and put a dot here. And we can go to 5 and put a dot here, right? And now we can solve for our vertex, right? Negative b over 2a, if you remember that. Negative b over 2 times a. So negative b is negative 6, right? Negative, 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 negative 6 over 2a, which is 2 times 1. And so that's positive 6 over 2. So at 3 is our vertex. So now we plug that in, right? So we solve for f of 3, right? And that's going to be 3 squared is 9 minus 3 times, or 3 times negative 6 is minus 18 plus 5, right? So f of 3 here is equal to 9 minus 18, which is negative 9, plus 5 is equal to negative 4. So at 3, negative 4 is our vertex. So now we can just draw our parabola here. And I am not the greatest artist, as we've talked about. That is ugly, but that's fine. Okay, so we see how that works, right? Let's say what we do with our, which is right up here, x cubed minus 2x squared, right? So our factors are plus 3 minus 3, negative 2, right? X plus 3, x minus 3, and then x equals negative 2. And our zeros are at 3, excuse me, at negative 3, 3, and 2. Okay, so we've found our zeros, and we're going to go ahead and just plot those for now. So this is at negative 3, and this is going to be at 2, and this is going to be at 3. Now, one of the things we can do with the quadratic, or excuse me, a cubic function, we can plug 0 in here and see what at x equal to 0, what's going to be the value of this. So 0 cubed, 0 squared, and 0 here, that's all going to be 0. So this is going to be 18. So this is going to be up here somewhere. Okay. So what we're going to have to do, and we'll take this, and it actually is going to peak up here. So we'll just come back down here. And, oh boy, that's a mess. All right, so there's this. And this comes down like this, and it comes back up like this. Okay. Now, if we take our calculator and we plug this equation in here, and we also work with our window, knowing that I'm going up to 25 with this, and I go ahead and I graph this, that's about where we get. We almost get to 25. So here's a nice looking graph, a much better looking graph here than what we had. Okay. So use the calculator to help you get the graph and practice these two problems here. Have a great day.